Hello, today I would like to show you how to build a buck boost converter with Simulink. The buck boost converter regulates a DC output voltage at a level that can be lower or greater than the voltage source. For it, we need a DC voltage source. We can choose, for instance, 20 volts. Then we need an ideal switch with a pulse generator for controlling the switch. We will choose a frequency of 20,000 Hz and a duty cycle of 75%. Now we need a diode. And we can remove the diode losses. Finally, we need an inductor, a capacitor, and a resistor. So first, the inductor, then the capacitor, and finally the resistor, which is the load. We also need two current measurements, one for the inductor and one for the diode. And for the output voltage, we need a voltage measurement. We can link the component together. And we can add the scope for displaying the signals. So the number of input is 4. One for the pulse generator, one for the current through the inductor, one for the current through the diode, and one for the output voltage. Don't forget to add the power grid block for solving the circuit. Alright, there you go. I will show you first the continuous mode and then the discontinuous mode. For the first mode, so the continuous one, the current through the inductor is always greater than 0. I will choose the inductor value and the capacitor value. So, when the interrupter is on, the diode is reverse biased and the current flows through the inductor, which stores some energy. But when the interrupter is off, the energy stored in the inductor is sent to the load and the input voltage is disconnected. So now we can run the circuit. Okay. So we can see in the second graph the current through the inductor is always greater than 0. And in the third graph, the current through the diode is sometimes 0 and sometimes the same as the inductor one. In this mode, the output voltage is equal to the input voltage multiplied by the duty cycle and divided by 1 minus the duty cycle. So according to the value of the duty cycle, we can have an output voltage greater or smaller than the input one. So in this case, it's higher But if we change the duty cycle, for example, into 25%, we will have a smaller output. Notice in this case, the output voltage has an inverse polarity. That's a particularity of this circuit. If we reduce the value of the capacitor, we can see the output voltage contains more ripple. As you can see on the graph, the voltage is less smooth. If we reduce the inductor value, the current through the inductor will reach zero before the end of the period. That's how we can have the discontinuous mode. We increase the capacitor value for keeping the reduction of the ripples. In this case, the output voltage is equal to the input voltage multiplied by the duty cycle and divided by delta. And delta is the time required for the inductor current to decrease. In this case, it's more or less 10 microseconds.